Our project was the impacts of water stress on the growth of cos, iceberg and mignonette lettuce, and our group consisted of Lauren, Mean and Millie. Our project was undertaken as the agricultural crop industry utilises the highest amount of fresh water within Australia, which in conjunction with extended periods of drought and increasing population size has put an immense strain on both our current and future water availability. Therefore, the need to understand the minimum water requirements for produce is beneficial to help relieve the stress of the agricultural crop industry on water supply.
So as Lauren was explaining, our project intends to investigate water requirement levels and overall water stress on lettuce. So we decided that the aims of the project are to understand the minimum water requirements to produce healthy lettuce, but also to understand whether different lettuce varieties respond differently to water stress. Our objectives were to determine the minimum quantity of water needed to maintain healthy plant growth, and also to determine whether lettuce can grow within a limited water environment. To determine which lettuce variety, seen in Figure 2, produces the best harvest with the least amount of water. From these, we have formulated the research question for the project to be: does reduced water availability make lettuce growth decline? If lettuce growth declines, what is the minimum water requirement for healthy lettuce growth? Within our scope, our study was carried out within all COVID-19 rules and regulations. It analysed the effects of 6 different water stresses on the lettuces and was undertaken in 3 different locations within New South Wales to determine which location achieved the best harvest outcome. We disposed of the experimental samples appropriately and according to the manufacturer's guidelines, and it only cost $25 at each location. Our study did not include interaction or involvement from general public, cause any harm or change the environment. There was no use of excessive amounts of water or space, did not impede on public council space, nor cause any risks to public health, and there was a limit to the study as it did not look into any other factors such as salinity or nutrients, due to limited access to the necessary equipment and laboratory.
So now we're up to our method. So I determined the water treatment by doing a separate experiment with a similar cup size to the pots that were determining the saturation point. This was found to be the volume of 100%. Then I divided accordingly to each percentage treatment. And here we have the respective volume of these treatment, which is no water, 3 mils, 6 mils, 9 mils, 12 mils, and of course the saturation, 15 mils. So for the setup, we used 18 seedlings, all for the 3 variety, 18 50 mils square tube pots, Scott's Performance potting mix, and all were bought from Bunnings. We used our own kitchen scale, ruler, tape measure, and we also put the seedlings under a covered area that allows access to sunlight but eliminates natural rainfall. To measure our different factors, again, we use kitchen scales, tape measure, measuring tube, and tap tank water to water our plant accordingly to each treatment. The measures taken were weight, height, circumference, photos of the overall appearance. For the weather condition, we measured temperature, humidity, precipitations, and others. We also measured the root length in the beginning when we're transplanting and the final harvest. For the data analysis, we determined the difference between the 3 measured factors. For example, for plant weight, we used the values obtained from the measuring date minus the previous measured value. And that goes the same for height and circumference. So the key results that we've obtained. For all the 3 factors, so height, weight, and circumference, we averaged each water treatment of the 3 species over 45 days, and we also included standard error for each factor. For height, we can see that mignonette grew the tallest in 60%, iceberg was at 80%, and cos was at 40%.
Here we have Figure 7, which displays the average plant weight differences across the treatments. This graph demonstrates the water retention levels across water treatments, as weight is indicative of the amount of water being retained in the soil. So if the sample is heavier, then there is a higher water retention. Across all varietals, the weight results increased the amount of water throughout the study, with the 100% treatment having the largest weight gains. Climate can have an impact on weight as higher transpiration levels increase water loss and vice versa for cooler, high precipitation days, leading to a greater variance for the 40 to 80% water level treatments.
As you can see with the circumference results, there was quite a big variation between both the lettuce variety and the water treatment. As you can see, the iceberg had the best circumference within the 60% and upwards water treatment, while Mignonette was in the 80% water treatment and the cos was in the 60% water treatment. And this was due to both the lettuce variety and the way that they were growing within the pots throughout the experiment. Both the cos and the Mignonette lettuces were growing upwards in a confined way, while the iceberg lettuce was growing both upwards and outwards. This table presents the differences between the root length at time of transplant and harvest. And as you can see, the cos lettuce only gained root length within the 40% water treatment, while the iceberg saw increases within the root length in the 60 and the 100% water treatment, and the Mignonette saw an increase in root length within the 20, 60, 80, and 100% water treatments.
We counted and averaged the number of healthy leaves at that time of harvest, and you can see that the best harvest output in cos are 5 leaves in 40%, iceberg are 7 at 80%, and Mignonette is at 4 leaves at 100%. Looking at the weather patterns averaged over the 45 days, we can see the different climatic conditions that the lettuce grew in. So cos was grown in an urban area with strong wind and warmer nights. Iceberg was grown at a semi-urban area with many frosty morning and colder nights. Mignonette was grown in a rural area with most humidity yet less wind. So now we have a look at each lettuce growth over the 45 days. For cos lettuce, we can see that in the top view, the 0 and the 20% are starting to die. Surprisingly, each one of the 60 and 80% and 100% also died. Here in this side view, again, we can see that 0% and 20% of the plants are slowly dying. But surprisingly, the height of the 100% looks shorter than the rest. I also recorded the root length at the time of harvest, and here is root 1 to 11. Of the 0 to 40%, we can see that 40% did grow, but there isn't much root to it. However, here in the 60 and 80% of roots 12 to 18, we can see that there's plenty of roots. However, there's less plants here, indicating that the majority of the plants have died.
This variety was the iceberg lettuce, and as you can see, it's a very hardy lettuce as all 18 pots survived the whole 45 days experiments. So this means that you can grow iceberg lettuce with 0% water for 45 days. However, if you want to produce lettuce with viable leaves, the minimalist water requirement you can have that we found was 40%, which is 6 mils of water every second day. But if you want the best harvest outcome, that was seen in the 80% water treatment, which was 12 mils of water every second day. In terms of the root length at harvest, as you can see, the 0% water treatment had no roots, which corresponds to having no water. And the 20% and the 40% water treatments had quite substantial root growth for the water availability which they had. And in regards to the 60, 80 and 100% water treatment, there was quite substantial root growth, and as you could see it pre-harvest growing out the bottom of the pots.
The mixed Mignonette lettuce seedlings are located on the Central Coast in a regional agricultural area. The seedlings are placed in a part shade area that receive sunlight from 7 to 1 p.m. Mini Net 2 displays the monitoring of the growth of Mini Net lettuce seedlings over a 45-day period. The photos along the bottom of the slide display the seedlings at harvest, and we can see that the minimum water level is 60%. This study has shown that the 100% water level treatment is having the best effect on Mini Net seedlings. Overall, the Mini Net variety was the least hardy of all the varieties.
In conclusion, this experiment revealed that the minimal water requirements for cos and iceberg lettuce was 6 mils of water every second day, and for Mini Net, it was 9 mils of water every second day. The best harvest output for cos lettuce was in the 40% water treatment, while iceberg was in the 80% water treatment, and the Mini Net was in the 100% water treatment. And lastly, the iceberg lettuce was the hardiest lettuce, followed by the Mini Net and the cos.
There are several personal learning outcomes that we've experienced during this study, including the 3 different varietals have different base water needs. 6 mils of water was the minimum requirement for the cos and iceberg lettuce, whilst the Mini Net had a minimum of 9 mils to be a viable agricultural product. This is the baseline for our experiment to demonstrate that in drought conditions, certain lettuce are able to survive and grow at just 40%. Other learning outcomes include the differing levels of hardiness across the 3 lettuce varieties. Although they could all withstand the lower water levels, the iceberg was considered to be the hardiest as it lasted in a better growth stage throughout the study. A big personal learning outcome for our group was the factor of spatial needs of all the lettuce varieties. These small containers hinted the growth of all the lettuce, although we did see significant differences in growth stages for the different water treatments. And here are our references, and thank you very much for watching our seminar.